Hello, everybody.
Hi.
I'm Pam, and I'd like to be talking today about the intelligent traffic control systems for bias road intersections. That's a lot, but unlike many of the other things that have been brought up in the class, mine isn't really a real-world situation as such. It's more of my world, and I'm sure when we're done with this, we'll realize how this is relevant to a lot of us. So I'm going to start by building up the scenario for the problem. If this thing works. Great. Okay. So I want to build up the scenario for the problem. I want to give 3 quick real-life scenarios, then we can understand where we're going with this. It's almost midnight. You're going to have a quick snack, and you realize that, I don't have milk, so I'm going to drive down to the grocery store to get milk. And then you get to the intersection, and the light is red for weeks. I mean, you're just stuck at the light. And you're thinking to yourself, no one else is using the road right now. Why am I here? And eventually you get to get your milk. That is my scenario 1. 2 is, it's rush hour. You just got off work. And you're trying to get home. There's a lot of traffic. But you keep getting this intermittent stops for an intersection that no one is using as well. I don't know if anyone else gets that problem. Yeah. You're thinking to yourself, we are 100,000 of us want to move forward, and no one is using this road. Why am I here waiting? So that's the second scenario. And the third one is this: we have a ball game, and now a road junction that wasn't often used has become a major exit something, and because of how it was a minor road before today, and now it's major, that causes a lot of delays, which we don't expect. So I don't know if you get what I'm trying to draw here, but forward, yeah. I'm trying to say that our road intersections should be more intelligent than they are. How can we get this done? By gathering data and traffic patterns and building some sort of intelligent understanding of the road intersection controls that dynamically respond to how the road is being used at the time and give a more efficient use of the road. Because analog systems are not working as best as they can. So I'm going to start by defining a few things. The kind of intersections we have, I'm going to define the kind of biases we have, and I'm going to talk about the limitations of this system, then I'll talk about the system. If we think about it, we have only 2 kinds of intersections. By the way, I forgot to add that this thing is, it's not really very scientific or anything. This is my thoughts brought down to the presentation. So I may be wrong, and I'll be expecting a lot of feedback at the end of this. We have 2 kinds of intersections. We have the dual or multiple road intersections, which means that we have major roads intersecting. It can be 2, it can be more than 2, but each road is equally as important as the other. And we have major and minor intersections. This is what I choose to call them, where one road is probably more important to use than the little one. Now, I'm going to talk about the limitations of this system. The limitations of the system indicate that there has to be a bias for us to require an intelligent solution. This means that if each of the intersections are being used equally, then we do not need an intelligent solution to solve that. We just need appropriate time sharing to ensure that everyone gets to use the road at equal times. There has to exist a bias. Then we need an intelligent solution. Other limitations are traffic safety and the human factor. Traffic safety means that whatever technology we're preferring on this should ensure that there's, the intersections are safe, because from research and data, we see that most accidents happen at intersections. And the human factor means that if we are applying a lot of technology at the intersections, we should remember that the cars are being driven by humans, and that has limitations inherently. Now, the biases. I have identified 4 biases during which we need an intelligent solution to monitor traffic at intersections. One is the time bias, which means the time of day. So obviously, there's a time of the day when the road is being used more than others. Maybe the rush hour, morning rush hour, the evening rush hour, stuff like that. There's a traffic density bias, which means that there's a major highway. I'm trying to see maybe like the Route 4, for example. Route 4, loads of cars are passing by, and there's a minor highway, and there's a minor road intersected. So that automatically gives more prominent bias to the major highway and less to the minor intersection. And event bias, as I gave in an example, the ball game that converts a road that's not probably used as often to become a major exit route, and the intersection one as well. These are solutions that people have come up with. They have the Petronet traffic system, which says that when cars approach an intersection, there are little models of breakdown of how the road can be used. And some of these systems even say that we don't have to stop at intersections. When you get there, the car communicates with the intersection wirelessly, and the car gets to go ahead to make the turn that you indicate to make. Yeah, I think it's brilliant, but I don't see that kind of thing coming to life because of the human factor, which I hated earlier. And that also highlights the wireless communications at the intersections as well, which are trying to suggest that cars should be able to interact with each other, and then should be able to instruct each other on who has the right of way, and then we might need to get out of the primitive traffic light system. But here are the solutions that I think, using analytics and data. First of all is the phase system. The phase system kind of adjusts itself to the pattern of traffic on the road at the time. And this is instructed by traffic sensors that are located just the way Google Maps can tell if there's traffic or not. This system will have such technology. So when there's traffic, we have 3 phases that instruct the intersections on how to react to traffic, to mild traffic, to no traffic, and to a lot of traffic. So that's about the phase system. The second system I think will solve this problem is the queue system. Now the queue system, which is a bit more detailed than the phase system, has motion sensors, and what these do is they have instructions to carry out depending on the length of cars arranged at the intersection. So, for example, if the queue reaches 9 cars, do this. But if the queue often reaches 4 cars, do this. If there's no queue, do this. So that's the queue system, which will be driven by analytics as well. I try to put the role of analytics in this. I don't want to go through the process of bringing the whole thing, but I'm sure we can imagine how these intelligent systems have to be driven by analytics. You know, the responses of the system have to be driven by data which we collect, or which we probably have collected over time to program the system. My third suggestion is the time-based system, which proposes that there are 3 time bases for every road use, which is the rush hour, the non-rush hour, and the after hours. And then we program the system to react to such. So if it's a rush hour, you should probably give some streets, give some roads priority over others. If it's not rush hour, you can react in some other way, and if after hours, give some road priority over the others as well, driven by analytics. The fourth, and I think the final suggestion, is the adaptive traffic pattern storage system. Now, what this does, which probably is more in line with what he just presented, is the system kind of understands how the road works, and then self-suggests patterns to ensure efficient traffic flow. That's what the text says. It has a memory that stores patterns, a large range of patterns, that are triggered by certain activities. So if we have 2 cars waiting on here, and we have 4 cars waiting on here, that kind of tells you that we have more traffic on here than here. This is how you should execute the intersection and that kind of thing. I don't know if such technology exists, but I think that this probably will be, it's the most complicated, but I think this will probably be the best solutions at intersections, because this one is, it's kind of like artificial intelligence, and it self-learns and educates itself. The recommendations are, post-executing the suggestions, the traffic control system should be remotely controlled to ensure speedy response. So even though the traffic systems have been preset, they should also be remotely controlled by some central control tower or something. Why? Because of errors, to reduce errors, and this also ensures that they're working efficiently. You can always, without having to physically go there, monitor how they're performing. Solutions should be driven on data trends to reduce errors and for best efficiency. Intelligent traffic control systems should also have the feature to provide feedback. Now we're going to need feedback to further fine-tune the future solutions we're going to have. We're going to need feedback to ensure that the solutions that we have preferred are doing the right thing. And finally, safety is most important. So whatever we're doing, it has to ensure that there's no safety at the intersections. What's the result of this? We have a more efficient road per use time. The roads and intersections are being used in the most efficient manner that they can be used. And we have data that are gathered for future developments. The benefits: less time spent on the roads, less gas and consumptions at the intersections, and you have reduced road rage. Yeah. And those are my thoughts.